Hello and welcome back to part 2 of section 1.3 of geometry. Now let's complete the example problems together, starting with example 1, find distance on a number line. We will use the number line here to find distance B, E. So we're going to start at B and travel all the way to E. That means we are going from negative 6 up to positive 2. Means we need the distance between negative 6 to 2, but that's always going to be an absolute value of distance. And from negative 6 minus 2 is negative 8, and the absolute value of negative 8 is positive 8. So the distance BE, my pen is not writing as well as I would like it right now. BE is 8. Example 2, find distance on a coordinate plane. Find the distance between point C at negative 4, negative 6, and D, 5, negative 1. Since this is a two-dimensional distance, given the x and y coordinates here, we're going to use the good old distance formula. That distance is equal to the square root of the sum of two squared pieces. Each piece itself is the distance in one dimension. So it'll be the difference of two like coordinates. So x2 and x1, or y2 and y1, and the order of anything does not matter as long as you pair like with like. So this will be the distance, the square root of quantity, let's go 5 minus negative 4 squared, plus the quantity negative 1 minus negative 6 squared. 5 minus negative 4 is the same as 5 plus 4, which is 9, so this is 9 squared. Negative 1 minus negative 6 is the same as negative 1 plus 6, which is the same as 6 minus 1. 6 minus 1 is 5, so this is 5 squared. So this is equal to the square root of 9 squared is 81, 5 squared is 25, and 81 plus 25 is 106. 106 is not a perfect square, so we will leave this as the irrational number for now. And since this is pure coordinate plane, no units were given. Example 3, find midpoint on a number line. Jacinta hangs a picture 15 inches from the left side of a wall. How far from the edge of the wall should she mark the location for the nail the picture will hang on if the right edge is 37.5 inches from the wall's left side? So notice this is 15 inches from the left, 37.5 from the left. We want the location of the nail. The nail for hanging a picture, a single nail, would naturally be the midpoint of the picture. So real quick diagram here. If I have my left side of the wall, we'll call that 0. I then have 15 inches to the picture, and I have 37.5 inches to the far edge of the picture, which means I can think of this as two coordinates, one at 15, one at 37.5, and I want to know the midpoint between them. Midpoint is nothing more than the average, so I'm going to take 37.5 plus 15, all divided by 2. 37 plus 15, excuse me, 30, 40, that's 52.5 divided by 2. Half of 50 is 25, half of 52 would be 26, half of a half is a quarter, so 26 and a quarter. This is a word problem, so we must include units. 26.25 inches. Example 4. Find midpoint in the coordinate plane. Find the coordinates of M, which will be the midpoint of segment ST for S at -6, 3 and T at 1, 0. The general midpoint formula is the average of both coordinates. So just make sure, we'll label these x1, y1. We'll call this x2, y2. We want to add the x coordinates together and divide by 2. And we want to add the y coordinates together and divide by 2 to find their average. So this will be the average of -6 and 1. And then for y, it will be the average of 3 and 0. Which will give us -6 plus 1 is -5 over 2. And this is 3 plus 0 is 3 over 2. And you could leave it as improper fractions or rewrite that as mixed numbers or decimals. We're just dealing with halves here, so I'd accept either version. On to example 5. Find coordinates of an endpoint. So here we're working backwards. We will be given coordinates of J. Find the coordinates of J. If K at -1, 2 is the midpoint, so notice K is the midpoint of segment JL, L has coordinates 3, -5. So I already know that K is the midpoint. So this operation up here comes down and it will be equal to J, which tells me two things. It tells me, since this is my x coordinate and this is my y coordinate, it tells me some mysterious x coordinate for J, we'll call that x sub J, plus x for L, the 3 divided by 2, is equal to K's x coordinate, -1. And it tells me that some mysterious y coordinate for point J plus the y coordinate of the other end L, -5 divided by 2, is equal to the midpoint's y coordinate of 2. And we can just solve both of those tiny equations independently. So let's multiply both sides by 2. X sub J plus 3 equals -2. Subtract 3 from both sides. X sub J equals -2 minus 3 is -5. And multiply over here, both sides by 2. Y sub J plus -5 equals 2 times 2 is 4. We could just simplify this to subtract 5. So we will add 5 to both sides. Y sub J equals 4 plus 5 is 9. Therefore, the coordinates of, we're looking for J, are -5, 9. And finally, example number 6, use algebra to find measures. We are given this diagram of segment PR. We are told find the measure of P to Q, so this much is what I'm looking for here. If Q is the midpoint, Q is the midpoint, that is very important. That tells us that this segment is congruent to that segment, which means the distances are equal. So PQ equals QR, which means that the 9y minus 2 is equal to the 14 plus 5y. All we need to do is solve this equation for y. I have one variable, one equation, totally doable. Subtract 5y from both sides, and that'll get rid of them on this side. We'll be left with 4y's. Let's add 2 to both sides. 14 plus 2 equals 16. Divide both sides by 4. 16 divided by 4 is 4. Don't stop. This is not the final answer. We are looking for the measure of segment PQ. PQ is represented by 9y minus 2, so I'm simply going to substitute that in. 9 times 4 minus 2. 9 times 4 is 36. Minus 2 leaves 34. Final answer. This concludes the example problems for section 1-3. So long, farewell, and enjoy the rest of your day.